All right, there we go. All right, so 10-2, actually starting to run hypothesis tests. You guys don't understand how exciting this is. This is really very exciting. So statistically significant is when the observed results, so whatever you get from the study running the hypothesis test, when those results are unlikely under the assumption that the null hypothesis is true. So again, every time we're setting up a hypothesis test, what we think and or want to happen is the alternative hypothesis. So, meaning that if the results we get are unlikely if the null is true, that's good for what we wanted or thought would happen, because if it's unlikely that the... All right, so if it's unlikely under the null being true, then that means that if we get that result, that's good for what we actually want to happen. When we do a hypothesis test, we have something that is called a p-value. Notice that the p is capitalized, likely because lowercase p stands for population proportion. So p-value, we actually just write out p-value. Again, with a capital P. And what the p-value represents is the probability of observing a sample statistic, so, you know, a p-hat or an x-bar or whatever statistic we are looking at, that is at least as extreme as one that would be observed under the assumption that the null is true. So again, this is helping us to determine if it's statistically significant or not. If our p-value is really small, then that means the probability is really low, which means that it is super unlikely to happen if the equals is true. And again, our general want is that we don't have the equals being true. So that's what we kind of want to happen there. So we do, just like with confidence intervals, we do need to check to make sure requirements are met. So they will ask you to do that on the final exam. Obviously, they're going to ask you to do that in the homework. So to verify the requirements, the p-null, q-null, those are, the p-null is the value that's actually in your symbolic statement. So when we practiced writing out the null and the alternative hypothesis, whatever value is on the other side of the equal sign or the less than sign, that's your p-null. So that particular value, we take n times that. Q-null is 1 minus p-null. So very similar to NPQ greater than or equal to 10. We're just using the actual value that's in those null and alternative hypotheses. It has to be simple random. Again, generally, if it doesn't, you're either writing says random or you're writing assume random, because sometimes if we meet the other ones, they let us get away with number 2. This guy on the, some of you messed this up a little on the concept check last time. So you actually have to solve this, right? So if they give you a little n, you have to solve this for big N, the population size. Some of you just said, like, whatever little n was, you said, oh, the population, you know, all adult Americans is bigger than that. It's not that it has to be bigger than this, it's that it has to be bigger than this. So you have to get that population size alone first before you state that it's bigger. So if you did mess that up on the last concept check, I corrected it in the comments. Make sure you look at those. But again, you can't just write out this. You have to actually solve it and then show that that is actually met with the values or the situation. So steps for testing a hypothesis about a population proportion. So everything in 10.2 is proportions. And then our final section, 10.3, everything will be about a mean, just like we did in Chapter 9 with the confidence intervals. So first is, of course, to determine the null and the alternative. It will ask you to write it out in words if it wants it in words. Otherwise, assume that you can write it symbolically. Select a level of significance. Often this is done for you. So it will say use alpha equals 0.1 or use alpha equals 0.01. If it does not select a level of significance for you, then just go middle of the road. Use alpha equals 0.05 if not told what alpha to use. Again, we talked about this in 10.1. It depends on how serious a type 1 error is as far as what we will choose. But again, if they don't choose for us, then generally we choose the one in the middle, which is 0.05. Test statistic, this is the formula, so we're going to take p hat minus p naught. So whatever the sample proportion was minus what we think we are testing, and then we do square root of p naught q naught divided by n on the bottom. Then we are going to take that test statistic and we are going to use table 5 or StatCrunch to compute the p-value. So I will show you both. Again, I believe in the homework I asked you to just do 3 of the problems using the table. The rest of them, StatCrunch is obviously less time consuming, so the rest of them you can use StatCrunch. Just as always, make sure you write down what you put into StatCrunch. You don't always have to pull the screenshot, but you have to tell me what you did, not just write StatCrunch. When you are using the table, it is going to matter whether the test you are doing is two-tailed, left-tailed, or right-tailed. So this graphic kind of tells you exactly what to do. So if it is a two-tailed test, the p-value is going to be 2 times the probability of your z being greater than the absolute value of your z naught. And again, we're going to do an example where I actually show you with the numbers and with the table that will hopefully make that make sense. For left-tailed, it represents the area to the left. That's the p-value. For right-tailed, then the area to the right is your p-value. So again, that should make sense because probability is area. And since p-value is probability, that means over here we've got these two. Over here we've got this. And then right-tailed, we've got that area right there. As we talked about in Chapter 9, when we run a hypothesis test, we actually go to the exact same spot in StatCrunch that we did for confidence intervals. It's just choosing the different like little radio dial button. So you're going to go to stats, proportion, stats, one sample. That's all the same as in Chapter 9. But the difference is that you are going to choose the hypothesis test radio button as opposed to selecting down for a confidence interval. You will have to enter the value of the proportion that is stated in the null. So this is going to be your P naught. You're going to have to state what P naught is in there. Choose which type of test it is. So is it two-tailed, meaning that we have a not equal sign? We talked about this in 10.1. Left-tailed is a less than sign. Right-tailed is a greater than sign. You'll have to select the correct sign for that before you click compute. Once you have done that, you will, in those first 3 steps, you've stated the hypotheses, you have calculated a p-value. Step 4 is what we call the decision step. So whenever it asks what decision, and it usually uses that language on the final exam. So on the final exam, it will say, what is the decision? That is not the same as saying, what is the conclusion? The decision is step 4, and all the decision is to say, reject the null hypothesis or fail to reject the null hypothesis. That's the decision. The conclusion is when we use the script. And as I mentioned in 10.1, once we're actually doing the full hypothesis testing, we state the level of significance in the script as well. So for the decision step, if the p-value is less than your alpha, so this is why the level of significance matters, because that's what we're comparing to our p-value. So if the p-value is less than alpha, we reject the null hypothesis. So the saying that, I don't know, they always say, if p is low, the null must go. So if it's very small, then that means that we are going to reject. And again, like we went over and hopefully you've practiced in 10.1, when our decision is to reject, then that means that when we state the conclusion, we will say is. If the p-value is not less than alpha, so it's either equal or it's greater than, then we would say there is not, because we would fail to reject in the decision step. So decision is either reject or fail to reject. Those are the only 2 choices in step 4. When we write the conclusion, same as what we talked about in 10.1, we either say there is, if we've rejected, or we say there is not, if we have failed to reject, and then the rest of it should read the same. Most of you on the homeworks I just gave back did a really good job on stating the conclusion correctly on the confidence intervals, but there were a few of you that didn't follow the script. Again, if it has a script, you have to use the script. So there is or there is not sufficient evidence at the, and then whatever alpha equals. So alpha equals 0.1 or alpha equals 0.01, whatever alpha we're using. Level of significance to conclude that. And then we just fill in the alternative hypothesis real life statement in words. So the only time we would write this symbolically is if we actually didn't have a real life situation to fill in. Otherwise, this should always be like a full sentence about what we were testing or what the situation is that we're actually talking about. So a full conclusion might say, there is not sufficient evidence at the alpha equals 0.1 level of significance to conclude that the formula sheet increased exam scores by more than, 10%, or whatever it is we were studying, right? I just made that up. But you're making a real life statement in your conclusion. There we go. All right, so example 1, determine the critical values for a left-tailed test regarding a population proportion at the alpha equals 0.01 level of significance. So these critical values are the same things that we've been doing since chapter 7, where we are using the normal calculator, you're drawing the curve, and you are rounding your answer because the critical value in this case is a z-score. It's a z values. So when we draw our curve, z is the label on our axis. And if it is a left-tailed test and alpha equals 0.01, then that means that they are saying that the area on the left is 0.01. So just making sure that we understand that that is what our alpha is representing. As far as the stat crunch work, it's the same as what I've been asking you to write. So you should write out what you are actually typing into StatCrunch, which would be this. And then we will actually do that. And where's my StatCrunch? There we go. So if you go to Stat and Calculators and then go to Normal, since it is Z, then we should be able to get that value. Again, if it's Z, why is it not? I'm going to switch over and then switch back. I don't know why it wouldn't do that. But remember that our mean is 0 and our standard deviation is 1 for all of these. When I click compute, I get negative 2.326, so on and so forth. Remember again that these are z-scores. They should always be rounded to 2 decimal places. So I would say negative 2.33 for our value there. All right, example 2, we are actually going to go through all the steps. Because there is not a real life situation on this, when we get to step 5, we will have to use the symbolic one on this because there is no real life situation given. It does say, it reminds you to be sure to verify the requirements of the test. So to verify the requirements of the test, we would have to check that n times p naught times q naught is greater than or equal to 10. So when, again, p naught is going to be the value that is in your hypotheses. So in this case, p naught is 0.9. So if that is p naught, then that means that q naught is going to be equal to 0.1. And so for the requirements of the test, we would do n, which is 500, times 0.9 times 0.1, and verify that that is greater than or equal to 10. And again, what you are writing down is just whatever it gives you in this case, because we have all of the pieces that we need, and that gives us 45. So we can say, yes, 45 is definitely greater than or equal to 10, so it has met that requirement. Again, step 2, it doesn't say anything about this, so we will go on to, and again, normally this would be done in a real life situation where we have more information, but we would generally say that we would assume that it's random. And then step 3, we would say n, which is 500, less than or equal to 0.05 capital N. Now in this situation, because they didn't give us the real life meaning, but I do want to practice this because some people missed it in the last chapter. So I'm actually solving for the population size, and in this case that gives me 10,000. So 10,000 less than or equal to the population size. Now, again, in this case, we really can't verify because it didn't give us the situation. But I would say that in most cases, our population, if we're talking about all teenagers or all college students or all Americans, we would simply have to say there are more Americans than 10,000, or there are more than 10,000 college students, is how you would verify that if you're not given capital N, which we normally are not. So that's what you have to run through for verification. Here we are going to use the table in order to run through the steps. So step 1 is obviously done for us, so I'm not going to rewrite it because it's right there. So this is step 1, is to state the null and the alternative hypothesis. So null is p equals 0.9, and the alternative is p not equal to 0.9, which means this is what type of test would we be running of these guys here. Two-tailed, left-tailed, or right-tailed? Two-tailed, right. So not equal to in the alternative hypothesis means that it is a two-tailed test. So first thing in step 2, already done. So again, I'm not going to rewrite it. There's step 2. We know what alpha is. It's 0.05. Most of you obviously don't copy the problem in your homework. If you do, then you can do this, but otherwise you would need to write it out on your paper. We just already have it written out on the paper here. Step 3 is to compute our test statistics. So step 3, and you do not, by the way, need to label the steps in your homework. I am only doing that so you, when you look back at the notes, can see exactly what we did for each step, but you most definitely do not need to do that yourself on the practice. I can look and find all the things that I need. So step 3, I'm going to use the formula. So I need p hat, which I do not have at this point, so that probably is my first step for step 3, is to calculate p hat. P hat is x divided by n, so in this case, 436 over 500, which is 0.872, because p hat has to be plugged in to find my test statistic z naught. So z naught equals, again, formula is right here. So p hat is 0.872, so that goes first. And then it says minus p naught, which p naught we already marked is 0.9, divided by the square root of p naught times q naught, so 0.9 times 0.1, divided by the sample size, which is 500. So when I do this, again, you can type that whole thing into your calculator at once. So if I use alpha y equals and choose the fraction shortcut, 0.872 minus 0.9 on the top. In the denominator, put the square root and then another fraction. And 0.9 times 0.1 in the top and 500 in the bottom. And it will do all of that at once. The test statistic is also like a z-score. So we are getting a critical value z-score, and then we have a test statistic z-score. So these should also be rounded to 2. So I have negative 2.09 is what I would write for that answer. So negative 2.09. That is the test statistic. Then in step 3, which is where most of the actual work is, it says then use table 5 or StatCrunch to compute the p-value. So again, I'm going to show you both, but we're going to use the table first. The table is on the back. of your notes. So what we need to do is we need to take our test statistic, and we've used this table before, but the whole number, the ones place, if you will, and the tenths place are both the row headers, and then the hundredths place is your column header. So when I look at the table, since my test statistic was negative 2.09, I go to negative 2.0 here, and then I make my way over to the 9 in the hundredths place, and this gives me my value for my p-value, which is 0.0183. So we will then, if we go back to where we were, our critical value, I shouldn't say p-value, our critical value is 0.0183. This is from the table, so write yourself a note. But that's where we got that. Now, sometimes the value from the table is the p-value, which is why I had said that originally. But how you know is based on this. Because if you look, and we've talked about this before, whenever you're using a table, at the top left, it'll tell you what the area is representing. So in this case, the area that the table gives us is representing the area to the left side. So if it's a left-tailed test, then that's our answer, right? If it is a two-tailed test, then we need to do what? Double it. And so that's exactly what it says down here, 2 times that value. So the p-value in this case is going to be 2 times our 0.0183, which gives us 0.0366. Got it. All right, that is the end of step 3. Step 3 is where the bulk of your work is, either the table work or the StatCrunch work, because what you end up with at the end of step 3 is the p-value. So that's our p-value. Step 4 is the decision. And again, that's purely based on comparing the p-value to the alpha value. So step 4, we look at the p-value, we look at the alpha value. In this case, the p-value is less than the alpha value. So that means that our decision should be to reject the null hypothesis. Again, when it asks you for the decision, that is all you have to say. If it's asking you to run the hypothesis test, then you need all the steps. But if all it's asking for is what is the decision, then you say reject H0 or fail to reject H0. So in this case, we are saying that we are going to reject. So then step 5 is to write out our conclusion, which I'm really going to have to squish here. We don't have a real life situation, so that makes a little bit less writing. But if we reject, we say there is. So we would say there is sufficient evidence at the alpha equals 0.05 level to conclude that And then here's typically where we would fill in whatever the alternative hypothesis was in real life. Here we don't have a real life situation, so we just use the symbolic alternative hypothesis. So we say P not equal to 0.9. The conclusion always uses the alternative hypothesis, which is the same as what we did in 10.1. Last example, Nexium is a drug that can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of Nexium claims that more than 94% of patients taking Nexium are healed within 8 weeks. In clinical trials, 213 of 224 patients suffering from acid reflux disease were healed after 8 weeks. Test the manufacturer's claim at the alpha equals 0.01 level of significance. So this is what a hypothesis test type question looks like, and you then have to go to do all 5 of the steps. Again, you don't have to label the steps. We did that once. I'm not going to do that part again, but we do need to make sure that they're all included. So first step is to state the null and the alternative. Again, unless it specifically asks you to state it in words, you can state it symbolically. Everything in 10.2 is P, because that's the parameter we're testing. So P, the manufacturer's claim is that more than 95%, so the alternative hypothesis is greater than 0.94, which means that the null is equal to 0.94. So that's step 1. Step 2 is typically given, so we just write it out. For step 3, we are going to have to type some things into StatCrunch. So you are going to follow these directions, and on the video you're obviously not going to be able to see my StatCrunch screen, but I will talk through what I am going to. So we go to stat. We go to proportion stats. We choose one sample. This is not with data. If it was, we would have loaded it into StatCrunch. It is with summary. We have to type in the number of successes and the number of observations. That is X and N. So the successes in this case were 213 and 224 was our N. So we type 213 in for number of successes, 224 in for number of observations. Under perform, we keep it on hypothesis test, and we type in that actual P0 value, so 0.94. Notice that it says H sub A instead of H sub 1. Some textbooks use that for the alternative hypothesis. Ours just doesn't. And so I changed that to a greater than, so that it says under HA, which is the same as H1, P greater than 0.94. If you wanted to show you the critical value, you can do that. You don't need to, because it is going to give us the p-value, which means I don't really need the critical value unless it asks me for it in this case. So when it pops up with the results, it is going to give you the p-value on the very far right. Now again, if you want the test statistic in StatCrunch, that is where it says Z-stat, so that would be 0.69. So Z-stat, let me go back to this. So it says Z-stat in StatCrunch. Again, you don't really need to write that down when you're using StatCrunch, because it also gives you directly in the last column the p-value, which is 0.2462. So that is step 3. So step 4, the decision. Should we reject or fail to reject? Is my p-value less than my alpha? No. No, it's bigger. So that means we are going to fail to reject. That's the decision. Fail to reject null hypothesis. And then this time we do use the script for the conclusion. We say, since it was fail, we say there is not sufficient evidence at the alpha equals 0.01 level to conclude that, and then it's the real life version, so whatever the claim was. So in this case, that more than 94% of Nexium patients are healed within 8 weeks. All right.